So I'm Brian Troutwine, and I am a software engineer that's interested in failure and what we can do about it.
And I'm Bruce, and this is a video series that talks about interesting historical failures, why they happened, and what we can do about them. I'm doing this series because I'm typically an optimist. I think about things the way things succeed, but I think that it's important for software developers to also think about how and why things fail as kind of an inoculation against this virus, if you will. So, Brian, what's on the docket this week?
Yeah, so this week I wanted to talk about the Boston Molasses Flood, which was an industrial disaster in 1919, where a 5-story tank of molasses, 2.3 million gallons of molasses, collapsed and flooded North Boston, killing and injuring a good number of people.
Molasses. I'm not sure that our audience will have ever used molasses. What even is it anyway?
Yeah, so molasses is a sugar product. It's pretty tasty on pancakes, but it's very effective for fermenting alcohol. So the tank was owned by the Purity Distilling Company, which is a subsidiary of the U.S. Industrial Alcohol Corporation. And their goal was to, at the time of the tank's construction in 1915, their goal was to manufacture industrial alcohol for war production. So alcohol is used in the manufacturing of powder, of high explosives, things like that. So for those of you that don't quite remember, 1915 was the first year of World War I. The United States did not enter the war until later. World War I ran from 1914 to 1918. But the United States was allied with, the Allies there against the Kaiserreich, and was selling munitions. So under the Wilson administration, the United States had attempted to stay neutral on the war, but also supply one side with munitions, which was actually fairly lucrative. This was the era of huge industrial business, sort of unfettered, or America's first wave of unfettered industrial capitalism. America had gone through a recession, I think in 1912 and 1913, and munition sales had really dragged America out of that recession. 9 million people employed in the munitions industry, where a couple of years before there was no such thing.
So we're talking about munitions production on massive scale, actually on global scale, right? World War I. Mm-hmm. That sounds like it has to be a massive tank.
It was. So the tank was 5 stories high. It was the largest above ground tank in the Boston area. It was one of the largest tanks in the country at the time, above or underground.
So that's interesting. Surely there were plenty of inspections as they were building this tank.
The fun fact about this era, there weren't really inspections. So nowadays, when you build a structure, you have to register the plans with a civil engineer that's unrelated to the construction. You have to undergo periodic inspections of the safety of the structure. You have to register the plans with multiple authorities. That doesn't exist in this period. In this period, the assumption is that if you are a large corporation and you are out to make money, then you will naturally do the right thing to protect your ability to make money. Not necessarily being concerned with, if you cut corners, you can make money faster, which is in fact what happened here with this tank. So at this time, Boston considered the tank to be a quote unquote receptacle, meaning that the only permit that was required to construct this 5-story, 2.3 million gallon tank was a permit for the foundation. Was the foundation valid? So when you construct a tank like this, it's common to fill it with water to check to see if the seams are good or not. This tank needed to be finished by December 31st, 1915, for reasons we can talk about in a minute. And they were running out of time to get the tank finished. So the project manager, a man named Arthur Gell, who was a treasurer, not an engineer, decided that the way they would test the tank would they would fill it up with water 6 inches deep. Remember, this is a 5-story tank. They fill it up with water 6 inches deep. The tank does not leak in that 6 inches, and they assume that it will not leak all the way up as a result. They avoid filling the tank up 5 stories, in part because they would have to pay the municipal water supply for that water, which is an expense they did not want to take on. In addition to they didn't have the time to take it on because of needing to meet the December 31st, 1915 deadline.
So let's talk a little bit about that deadline. There are some logistical reasons that was in place.
It's important to understand how molasses is made. So molasses is made by pressing cane sugar. Cane sugar is, especially in this period, harvested by hand in the Caribbeans. And it's loaded into great big ships and then brought up from the Caribbean up north. The way this type of manufacturing works is you contract out for a certain amount of your raw product way ahead of time. So the reason the Purity Distilling Company had this December 31st, 1915 deadline is there was a certain amount of molasses that was already on its way to Boston and needed to be stored in a tank. And if they had not had the tank ready, they would still have had to have paid for that molasses, but the molasses would have just been dumped at ocean.
Let me get this right. So we have this structure where we have tested that the foundation is watertight, but we have not checked at all whether the walls of the structure, whether the overall structure can absorb the weight of many tons of molasses.
Yeah, that's absolutely correct. And it's also important to remember that because this is World War I, this is the World War I era, it was common for ironworks to produce steel that was thinner than normal. So the Hammond Iron Works, which produced the steel for this project, delivered steel that was 10% thinner than it needed to be at the top. So you can imagine the steel starts out at normal thickness and gets thinner and thinner and thinner as it goes up, which is fairly common in this war period, when it was understood that you needed to get things cranked out as quickly as possible. But this tank was built this tank was not built in an isolated area. It was built in North Boston, near homes, other businesses. Potential failure of this tank is more catastrophic than it would have been if it were built in an isolated area. Also, to save on riveting, they used less rivets than you would normally use, so they really cut a lot of corners in the construction of the tank. Not even in the safety checking, which they did that too, but even just in the physical raw material of the tank.
So we're kind of, as you typically see in failure and disasters, we have just kind of the stacking of weaknesses.
It's very rare for a catastrophic failure to be one single thing. It's more often the confluence of little things that, taken in themselves, seem like rational risks to take on. But if you keep stacking them, you get yourself worked into a pretty nightmare situation.
So what happened first?
Yeah, so as soon as the tank was constructed, even in the very first delivery of molasses, it was noted that a couple of bad things happened when they started to fill it up. One, the walls wobbled as the molasses was being poured in. So the molasses is sort of pumped in from a ship. It was also noted that the molasses leaked out as soon as it was pumped in. Not something you want. The rivets themselves would leak molasses. So there's already noted even when this tank is constructed, a severe structural defect. The Purity Distilling Company did a couple of things to hide this issue. The first is they would periodically re-caulk the tank, which didn't help because it's a lot of molasses in there. The other thing is they eventually decided to repaint the tank to be brown to hide the fact that it's leaking. But it was known that the tank leaked molasses pretty aggressively, to the point where local children would come and collect molasses and to eat. So a lot of molasses leaked out onto the ground. All through the World War I period, you know, the tank is constructed in 1915. World War I ends in 1918. The tank is periodically filled up. It's rarely filled to capacity, however. So because this distillery is working 3 shifts, it's working 24/7, they are really not able to keep the tank full. All through this period, it's noted that the tank is rusting, it's leaking, it's flexing, there's weird pops and pings in it all the time. But the tank itself is only ever very, very rarely filled to the brim. Once World War I is nearing to an end, so you need less industrial alcohol. The distillery, at this point, the U.S. Industrial Alcohol Corporation has taken over from the Purity Distilling Corporation. At this point, the owner of the tank has decided that they're going to retool their distillery to produce alcohol for consumption. So prior to the war, they had produced alcohol for consumption. All through the war, they had produced a little bit of rum from molasses, but they decided that they were going to retool and try and produce rum for consumption, individual consumption. And they need to manufacture as much alcohol as possible because there's a year grace period. Anything they have on hand, they can manufacture in that period and sell it. But then after that point, everything is toast. So they decide to fill the tank. I think January 13th and 14th of 1919, the tank had been filled to capacity. So it was completely full. And warm molasses and cold molasses had been mixed together. And it's important to understand that when you mix warm and cold molasses, it starts to ferment. So the tank not only is full to the top, remember this is a tank that is by design structurally weak, leaks constantly, but it's also completely full now, and the molasses inside is fermenting. So people at the time note that the tank is making these very loud pings and pops, and it sounds like it's gurgling inside. And it's gurgling because it's fermenting. So January 15th of 1919 at 12:41 p.m., there's this loud growling noise from the tank. And there are 2 children playing next to the tank. And workers on the elevated train line are scolding them for playing next to the tank. Children would often cross that tank to go get free molasses. So the workers on the elevated line, so there's an elevated line that the tank sits right next to. It's the Boston Elevated Line, which is actually, the tank itself is 20 feet larger than the elevated line. So it sort of dwarfs this elevated train. So workers on the elevated line are scolding the children, you know, saying, you get away from there, etc. One of the children survived, and what he remembers is he's listening to these adults scold him. He hears this growling noise, and then he wakes up some weeks later because he's been dashed against a lamppost or something. His head has been crushed. He has a horrible concussion. His sister is drowned in the molasses.
Let's bring up the map. What happened next?
This land where this tank sat was not actually owned by the company. It was leased from the Boston Elevated Corporation. This is the Boston Elevated line. Part of the reason why the tank was rushed was it took a long time to lease this land. So here's the city wharf. The molasses ship would come in here. There was the pipe that ran and would feed into the tank. The fire station, this fire station right here is this fire station.
You talked about a building moved from the foundation. It's this one right here, right?
Yeah, exactly. So the photo that we have sort of the panoramic is at a degree to the map that we have. So you can sort of see the curve of the train track, and that matches, there's only the one curve there. So that matches with that panorama. So the fire station is off frame in the panorama, but you can really see what a giant wave of molasses that travels 35 miles an hour will do to a building. The second floor pancakes into the first floor, trapping 2 people, one person of which drowns in molasses after his stamina gives out and he can't lift his head up out of the molasses. So the whole area is just absolutely decimated. Buildings are picked up and pushed out into the harbor. Many people are swept away and drowned in the molasses and the harbor, and only found months later after they are swept ashore during a tide. So it's just an absolutely devastating accident.
So this happened pretty quickly, right?
I think the flood itself was over and done in a couple of minutes.
Now let's talk a little bit about the fallout and the lead up. So you've told me that in this disaster, one of the problems was that we were making this transition from the wartime footing to the peacetime footing. What else was going on here?
That's a really good question. So the Purity Distilling Company and then the U.S. Industrial Alcohol, as the transition is made out of the wartime footing, recognize that their sales of industrial alcohol are going to fall off to zero because there's just not any demand for munitions like there was during World War I. So they decide to retool to produce individual consumption alcohol again. They had done that before the war. They figured they can go back to it. It's less profitable, but it is at least better than nothing. However, in large part because of anti-German sentiment, the temperance movement has really had a lot of success, and so prohibition is going to kick in 1919. So this company recognizes that it has a much abbreviated window to retool itself and produce as much alcohol as possible before prohibition itself actually kicks in. So prohibition begins in 1919, but there is a year grace period for alcohol manufacturers to sell their wares before the government will come around and destroy them. So the Purity Distilling Company and U.S. Industrial Alcohol, of which Purity Distilling is a subsidiary, decides that what it is going to do is purchase as much molasses as it can, store it, and then ferment it, and then sell it before 1920 rolls around. And the consequence of that is that the tank is filled to the absolute brim. It had only been filled a handful of times prior to this because war production meant that the tank stayed relatively empty. So not only is this tank by design structurally weak, not only is the maintenance of the tank less than you might hope, it is, for one of the only times in its service lifetime, filled utterly to capacity, and it's filled in such a way that the molasses inside is actually generating carbon dioxide. So it's increasing the pressure of the tank. So any structural weakness is now being stressed by the weight of the molasses. It's being stressed by the increased pressure in the tank itself. which is ultimately what causes the failure.
So today, we would probably blame this on some type of a scapegoat, or at least the industrial complex would. Is that what happened?
Finding scapegoats is a pretty classic thing for an organization to do when a failure happens. At this time, violent anarchists were sort of the bugbear. They were everywhere. Everyone was afraid of them. The U.S. Industrial Alcohol Company blames an anarchist bomb for destroying the tank. There had been threats against the tank prior to this, so it does sort of seem natural to think, oh, sure, someone dropped a stick of TNT into the tank.
But what did the trial say?
That was their defense at the trial. No one's quite sure if they actually believed it or not, but they sure did go for it at trial. What was actually found at trial, mostly through the evidence of structural engineers, is that the construction of the tank was pretty shoddy. The safety margin or the safety factor in a project like this is the degree to which you can go past the calculated tolerance ambition for your object. So if I say if I'm going to construct a tank and I say I'm going to fill the tank up with such and such material and at such and such volume, then I'm going to say per square inch my tank has to withstand 10,000 psi. I will then say that my tank per square inch needs to sustain 30 to 40,000 psi. The idea there being that my actual safety goal or my actual tolerance is 10,000, but my safety factor is 3 to 4. That's pretty typical in an engineering project today, to give a safety factor of 3 to 4. This tank was designed with a safety factor of 1.8. So at the time, it was common to do a safety factor of 2. They decided to do a 1.8 safety factor, in part to skimp on costs. So the steel was thinner than it should have been. The tank itself was composed of curved steel plates that are riveted together and then caulked between the seams. The number of rivets that would be needed for a project like this are less than you would normally put, in part because rivets were pretty dear when the tank was constructed. Remember, it was constructed during World War I. So it was found at the trial that the construction of this thing was just all around shoddy.
So Brian, are we really talking about just a structural failure here? Is that all there is to learn from this failure?
It's definitely a structural failure, but that's not in the entire story. So the project manager for this tank was a man named Arthur Gell, and he was the treasurer of the Purity Distilling Company. And he felt that his reputation, his sort of professional reputation, was tied up with the construction of this tank. And because it had to be completed by a certain date, he was willing to cut as many corners as possible to get to that completion date. Because the safe operation of the tank was not the goal, it was filling the tank up and making a profit off of the tank that was the actual goal.
So Brian, this has turned into a modern interest of yours. You regularly show up to city council meetings to talk about things like this.
Yeah, so I make public comments. I live in the San Francisco Bay Area. It's an earthquake zone. So we have a housing crisis here. We do not build enough houses, and the housing stock that we do have, many of them are not earthquake safe. So we have buildings that are called soft floors, where the first floor is sort of an elevated garage. All of those buildings will collapse in an earthquake that is of sufficient magnitude, and they need structural repairs to even be moderately safe. There are, however, continual voices saying that we should work ourselves out of the housing crisis by cutting back on safety factors in our buildings, making them a little more prone to falling down. is not necessarily why we don't build houses, or in fact, it is not the reason why we don't build houses, but it does make it cheaper for people that construct houses.
A few
A
less
few less
rivets.
rivets, a
Yeah.
little thinner steel. Yeah, it
There you
makes
go.
it cheaper. It makes it more profitable to build housing stock.
And I've got a house on the river, and I've seen very much the same thing, not necessarily with the construction, but the laws that consumers need to protect themselves. You know, we know that we have had more floods in along rivers all the way across the country, and yet, you know, so I'm right on the river. You can see from this shot, I am not required to have flood insurance, which is amazing to me. But one of the reasons is that if you interpret the laws in a certain way, it allows the developer here to sell the houses for more because their customers don't have to buy flood insurance.
You know, in the era that this tank was built, there was almost no regulation on construction. You know, the Boston City considered the tank to be a receptacle, and the laws at the time were such that if you were building a receptacle, all you needed to have permitted was the foundation. So Boston City would come and they would check the foundation, and then that would be it. So the rest of this 5-story tank is completely unpermitted. There's no, it's almost hard to imagine in the modern era. There's no oversight. There's no publishing of plans with civil engineering authorities. There's no periodic inspection to make sure that the tank construction is holding up over time. Nothing like that. It is this disaster that causes us as a society to want those things, to say that we need regulatory oversight of buildings in the public space, that we need to have civil authorities that are engineering experts.
There are probably a couple of lessons that we could take here. So one of them is definitely that there's this idea of checks and balances and actually compartmentalizing those checks and balances.
There is this pernicious idea, and it plays out in the early industrial period in the United States, that the free market will necessarily look after its own interests. So it is not in the interest of profit making to allow your tank to collapse. And so the assumption at the time was that the manufacturer of the tank would take every necessary precaution to keep the tank in good working order. Obviously that didn't happen. The tank did collapse and many people died. The flaw with that way of thinking is that you will do the least amount possible to make a profit. That notion that we should start to roll back regulation has been a big one in my lifetime, that we can allow the free market to look after safety, which I see here in building codes. Bruce sees on the riverbank. It's an idea that we have to continually push back on as a society.
So are we talking about just questioning motivations, or is there some deeper lesson or particular motivation that we're talking about here?
Questioning motivations is important, but I think the important thing that underlies this particular disaster is the assumption that if you are able to derive a profit from a thing, you are also concerned about the safety of that thing. So what we see in this disaster is that the Purity Distilling Company wants to make a profit from this tank. The tank is intended to increase the efficiency of their operation, but they're also very interested in building the tank as cheaply as possible, using less rivets, using thinner steel, avoiding having to recaulk the tank as much as possible.
So we're talking specifically about the profit motive and about thinking about ways that we can balance that profit motive in a compartmentalized way, which I agree is really important. But we're not just talking about engineering and structural codes and politics, are we?
No, we're not. So the underlying political ideology at the time of the Molasses Flood was that the profit motive was necessarily for the public good, and that anything that was in pursuit of profit would be for the public good. And as a result of the Molasses Flood, there was a pushback on that idea that we needed increased regulation. The switch was that anyone that is affected, that people that are affected by something in society should have a say in that thing.
And we're starting to see some parallels in big tech.
We are. So, I mean, definitely in our lifetimes, we've seen a return to that notion that profit is necessarily for the public good. And we see that very, very much reflected in sort of, well, the culture of the software industry in my area, in big tech, like you say. The idea that anything that is done, to increase quote unquote innovation is always going to bring about utopian results.
And so then it's on each of us to kind of step in and recognize the potential harms, and to be part of those checks and balances as employees of these technical companies.
It's incumbent on us as employees to be concerned with the actual effect of the things that we are constructing. So technology is not neutral. Technology encodes the politics of the structure that funded that piece of technology. And it's also incumbent on us as citizens to actually be concerned as citizens, to be concerned with whether or not our legislators are captured by lobbying efforts of big business, of minority interests, to be concerned as a society for the good of everyone.
So as a programmer, as a citizen, you have agency, and it's incumbent upon us to exercise it. What's on the docket next time, Brian?
Next time, we're going to talk about a fun little bug in a fun little spaceship. Let me redo that. So next time,
go ahead.
Fun little spaceship. So twee. Next time we're going to talk about an interesting bug in the flight control system of the Space Shuttle Columbia, based mostly on a paper called "The Bug Heard Round the World." It's the computer failed to start up effectively. We'll get into it more next time.
Thank you so much, Brian.
Thank you.
So I'm Bruce Tate.
And I'm Brian Troutwine.
For Why Things Fail. We'll see you next time.